Okay guys, now I will explain the empirical and the molecular formula. Okay, first you have to know what is the empirical formula, and the empirical formula is a chemical formula that shows you the simplest ratio of an elements in a compound. Okay, then the molecular formula is also a chemical formula that gives you the total numbers of atoms of each element in each molecule of a substance. Okay, now I will read you the problem and we're gonna solve it. Okay, oxalic acid is a compound used in paints. A sample of oxalic acid was found to contain 1.94 grams of carbon, 0.116 grams of hydrogen, and 5.16 grams of oxygen. The molar mass of oxalic acid is 19 grams per mole. Determine the empirical formula and the molecular formula of this compound. Okay, the first thing we have to do is to take out the compound percents, which I already made a video about it, so that's why they are already rated. So if you want to know how to take them out, you can go to the other video. So after we have the compound presence, the next thing we have to do is to divide the percentage over the atomic mass of each element. So first we're gonna do 26.72 over carbon atomic mass, which is 12. Then 2.21 over hydrogen atomic mass, which is 1. And 71.07 over 16, which is oxygen atomic mass. Okay, after we do this, we're gonna put the results, which is 2.22, 2.18, and 4.44. Okay, so this would be oxygen, this would be hydrogen, this would be carbon. Okay, now after we have the percentages, then we have to figure out the atomic ratio. How we do this? We're gonna grab the smallest gram atom, which is the hydrogen one, and we're gonna divide each of these ones over each of the atomic mass, each of the atomic in the compound for the smallest gram atom. So we're gonna do the next things. First, we're gonna use the atomic mass. I'm gonna write it here for us to don't get confused. So it's 2.2, hydrogen is 2. And oxygen is 4.44. Here's our atomic mass for you to don't be watching here. So as I already told you, the atomic mass over the smallest gram atom, which is 2.20 for carbon, over the smallest, which is 2.18. Then for hydrogen, the same, 2.18 over 2.18, and for oxygen, 4.44 over 1.18. Okay. After we have this, we're gonna solve them, which the over results would be 1.01. Here would be 1, and here would be 2.03. Okay. Now we know this. We have to close convert the ratio to a whole number. So the carbon was 1.01, so we're gonna put 1. Then the hydrogen was 1, so it's already a whole number. And oxygen is 2.03, which would be 2. So we already have 1, and 2, and the next thing we have to do is just to put the numbers with the letters. So our empirical formula would be carbon, it will be carbon, hydrogen, oxygen 2. So this is going to be our empirical formula, and then from here it's so easy to get the molecular formula. The biggest number of the in here, we're gonna this number, which is the 2, we're gonna multiply it by 2 in each one, and we're gonna get the molecular mass like this. So we have to put the molecular mass same as C2H2 oxygen 4. This will be multiplied by 2 each of these ones, and we're gonna get the result. And that would be all.